So test is going to be Thursday, but that just means that we get an extra day to review and study. Classes are going to be super short tomorrow, so I'm not sure how much time we'll have to go over anything tomorrow, just in case math runs long or something like that. So we're just going to review today, and we'll see how tomorrow goes. For 4.2, we are just adding and subtracting. So we're going to combine like terms. For 3 and 4, when it says find the difference, what do I have to do first? Distribute the negative to everything behind it, and then just combine your like terms after that. Let's take a look at, we'll do number 7. Divide. So on the test, the directions will just say divide. You can pick whichever way you want. I would suggest synthetic division. I think it's a little bit easier for most people, but if you want to use long division, that's fine too. So for number 7, if I'm doing synthetic division, what goes outside the box? -1, perfect, because we changed the sign. What would go inside the box? 2, -5, 0, and 3. Awesome, because we were missing that x term, so I have to put a 0 in that spot. So for synthetic division, we drop down the first number, multiply the outsides, add the insides, multiply, add. This would be 7, multiply, -7, add -4. So then we just need to put our x's in it too. If I start with x to the 3rd power, what's my answer going to start with? X squared. It's always 1 less. So x squared minus 7x plus 7, remainder negative 4. So 2x squared minus 7x plus 7, remainder -4. All right, next page. Let's do a factoring one. So let's look at number 2. What would I need to do first to factor number 2? Take out the GCF. What's my GCF? 2p to the 4th power. So 2p to the 4th power comes to the outside. I'd be left with p squared minus 13p plus 42. We still need to factor it more. Do I have 2 factors of 42 that add to -13? -7 and -6. So in my parentheses, I would have p minus 7 and p minus 6. Then don't forget to include your GCF that you took out in the beginning in your answer. So this would be your answer. So this, it just says factor, so we're not solving it. Just factor it and then we're done. All right, let's take a look at 4.5, number 5. So 3p cubed is equal to 21p. Number 5. What would I need to do first to solve? Make it equal to 0. So subtract 21p, move it to the other side. So 3p cubed minus 21p is equal to 0. What could I do next? Take out the GCF. What's my GCF? 3p. So when I divide out a 3p, I'm left with p squared minus 7. Now here, these are equal to, all the questions are equal to in this section, so we have to solve. So we factored it all the way. Now what would I do to solve? Set them equal to 0. So we set each p is equal to 0. So 3p is equal to 0, and p squared minus 7 is equal to 0. So to solve my first little equation here, 3p is equal to 0, what would I need to do? Divide by 3. So what does p equal? What's 0 divided by 3? 0. P is equal to 0. Then for the second one, what should I do to solve? Add 7. So p squared is equal to 7. Then what would I need to do? Square root both sides. So what does p equal? Plus or minus square root of 7. Perfect. So these would be our answers. So if it's something that you can't take the square root of, that's fine. Just leave your answer as the square root. But just make sure you put that plus or minus if you're taking the square root of both sides. All right, so let's look at 4. So we are solving again. How would I factor this if I have 4 terms? Grouping. Let's try grouping and see if grouping works. If grouping doesn't work, then do last over first. But let's try grouping. What is my GCF of the first group? N squared. So I'm going to take out an N squared. Bless you. And what am I left with? N plus 2. What's my GCF of the second group? 9. So I'm going to divide out 9 or -9, because we need that to be an N plus 2, so we got to change the signs. So now I'm left with N plus 2. It has to be the exact same thing on the insides in order for grouping to work. That's equal to 0. So now I group the 2 insides together, so it'd be N plus 2. What goes into my second parentheses? N squared minus 9, the 2 on the outside. N squared minus 9. Perfect. Can this be factored anymore? Which one? The N squared minus 9 is the difference of squares. So what would go into my parentheses here? N minus 3 and N plus 3. Awesome. Because this is the difference of squares. Anytime you have perfect squares that you're subtracting, it factors into a plus and a minus. And then we still have that N plus 2 here. What should I do next? Set them all equal to 0. So we're still trying to solve here, so we need N equals as our final answer. So N plus 2 is equal to 0. N minus 3 is equal to 0. N plus 3 is equal to 0. So when I solve the first one, what do I get? N is equal to -2, +3, and -3. Awesome. So these would be our 3 answers. So let's look at the graphing ones. Anyone specifically you guys want to do from the graphing? Okay, let's do 9. So for the graphing, we start just like we would with solving. We just have to put it all on the graph. What would I do first to solve here? Take out the GCF. What's my GCF? X cubed. So when I take out that x cubed, I'm left with x squared minus 2x minus 15. Now let's see if we can factor more. Do I have 2 factors of -15 that add to -2? -5 and 3. Perfect. So this would break down into x minus 5 and x plus 3. What would I do next? Set them all equal to 0. So I have x cubed is equal to 0, x minus 5 is equal to 0, and x plus 3 is equal to 0. So in the first one, if I were to solve this, it would just be x is equal to 0. But how many x is equal to 0s do I have? 3. I have 3. So my multiplicity is 3, because I have 3 of them. Is that even or odd multiplicity? Odd. 3 is an odd number. If I have odd multiplicity, do I go through the x-axis or do I touch and turn? Through. So at 0, I'm going to go through. Now for the next one, let's solve. I get x is equal to what? +5. So how many, well, let's finish solving. What's the third one? X is equal to -3. How many x is equal to 5s do I have as my answer? Just 1. So my multiplicity is 1. Is 1 even or odd? Odd. So am I going to touch and turn or go through? Go through. How many x is equal to negative 3's do I have? 1. So I have multiplicity of 1. Is 1 even or odd? Odd. Do I touch and turn or go through when it's odd? Through. So all of my points I'm going to go through. Now we need to know what our end behavior is. So I have to look at this x to the 5th power. It's positive, so what's my right arrow going to do? Right arrow goes up. Positive or negative tells you what the right arrow does. So right arrow goes up. Is it even or odd? Odd. So are they going to go in the same direction or opposite directions? Opposite. So what's the left arrow going to do? Down. If the right one's already going up, the left one has to go in the opposite direction, so down. It's positive, so there's no like negative in front of it. So since it's positive, the right arrow goes up. Positive or negative tells you what the right arrow does. So let's graph this. I'm going to start by putting my points. So I have a point at 0, a point at -5, and a point at positive 5, sorry. -3 and positive 5. Now I can put my end behavior, my arrows. So the arrow on the left goes out of my point farthest to the left. The arrow to the right goes out of my point farthest to the right. All right, so now at -3, what did I say that I was going to do? Do I touch and turn or go through? I go through, so I go through the x-axis. Got to make my way over to 0. At 0, what did I say that I do? I go through, so I go through 0. And then at 5, what did I say that I do? I go through, so I go through 5. So our graph should look like this. All right, so let's look at 8. So first thing we have to do is factor it and solve. We've got to find our zeros. So how would I factor this? I could do last over first, but do I have two factors of 16 that add to -8? What? -4, -4. So what would go into my parentheses? Because this one's a little bit different. It starts with x to the 4th power. X squared minus 4 and x squared minus 4. Perfect. Can this be factored anymore? Yeah. We can factor it into x plus 2 and x minus 2, and both of them are the difference of squares. So another x plus 2 and x minus 2. So this was the difference of squares. Both of them. What would I do next? Make them equal to 0. So x plus 2 equals 0, x minus 2 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So what does x equal? -2, +2, -2, and +2. So I'm just going to write it on the side over here. So I had x is equal to +2 and x is equal to -2. How many x is equal to +2's did I have? 2. So I have a multiplicity of 2. Is 2 even or odd? Even. Remember, we're talking about the multiplicity. How many times that occurs? This 2 is even. If I have even multiplicity, do I touch and turn or go through? Touch and turn. Let's do the same thing with -2. How many -2's did I have as an answer? 2. So my multiplicity was 2. 2 is even or odd? Even. And if I have even multiplicity, we touch and turn. And then we also need to know the end behavior. So how our graph is going to start and end. So we're looking at our highest degree term here. So x to the 4th power. Is this positive or negative? Or positive. There's no minus in front of it here. So it's positive. So what's the right arrow going to do? Right arrow goes up. Because if it's positive or negative, that tells us the right arrow. Is it even or odd, the degree? Even. So do they go in the same direction or opposite? Same direction. So the left one goes up also. So I'm going to put my points on the graph. I have a point at -2 and a point at +2. And then I'm going to put my end behavior, the arrows. So out of my point farthest to the left, I have an arrow that goes up. And out of the point farthest to the right, I have an arrow that goes up. All right, now let's connect the dots. So we said at -2, we touch and turn. So I can't go through the x-axis, I just have touch at that point and turn. And then what do I do at +2? Same thing, touch and turn. So we don't go through, we just touch and turn. So our graph looks like a W shape. Any questions here? All right, let's do number 10 too. What should I do first for number 10? Take out the GCF. What's the GCF? -3x, perfect. So -3x is going to go on the outside, and what am I left with on the inside? X squared plus 5x plus 4. Now do I have two factors of 4 that add to 5? 4 and 1? Positive. So this would factor into -3x times x plus 4 times x plus 1. What should I do next? Set them all equal to 0. So -3x is equal to 0. X plus 4 is equal to 0. And x plus 1 is equal to 0. So how would I solve for x in the first one? Divide by -3. So what does x equal? 0. What about the next one? We subtract 4, so x is equal to -4. Perfect. And then the last one? Subtract 1, so x is equal to -1. So now we need to talk about the multiplicity. How many x is equal to 0s do I have? Just 1. So my multiplicity would be 1. Is that even or odd? Odd. Do I touch and turn or go through? Go through. How many x is equal to -4s do I have? 1. So my multiplicity is 1. Is that even or odd? 1. We're talking about 1, the number, the amount that I have, not the number. -4 does not matter. We're talking about how many. So this would be odd. If I have odd multiplicity, do I touch and turn or go through? Go through. How many -1s do I have? 1. So my multiplicity is 1. Is that even or odd? Odd. Do I touch and turn or go through? Go through. All right, so we also need to know our end behavior. We look at our highest degree term here. Is it even? Is it positive or negative? It's negative. So what does that tell us? Which arrow? The right arrow goes down. Perfect. Is it even or odd? So do they go in the same direction or opposite directions? Opposite. So the left arrow is going to go up. So I'm going to put my points on the graph. I have a point at 0, point at -4, and a point at -1. So out of my point farthest to the left, I have an arrow that goes up. Which is my point farthest to the left? -4. So out of -4, I have an arrow that goes up. What's my point farthest to the right? 0. So out of 0, I have an arrow that goes down. Now, what do I do at -4? Do I touch and turn or go through? I said before I go through. So I go through this point. What do I do at -1? I go through. So I go through -1. And what do I do at 0? Go through. So that's our graph. All right, let's take a look at the first 4 on the next page. So 4.6. We did number 1. So we're just identifying the number of solutions. For number 2, how many solutions would I have? 3. Number 2. What about number 3? 5. And number 4? 6. Awesome. All right, next, let's look at the next part. So we can either factor or use our last over first and do synthetic division to check and see what our answer would be. Let's do number 6. How many solutions am I going to have for number 6? 4, because my highest degree is 4. All of these are going to have 4 solutions. I have 5 terms, so I can't even think about grouping yet. So I have to use last over first here. So I need factors of my last over factors of the first. What's my last term? 6. What are factors of 6? 1, 6, 3, and 2. Perfect. And it's plus or minus of all of those. It could be positive or negative. 1, positive or negative 6, positive or negative 3, positive or negative 2. And what's my first one? Sorry. All right, so these are possible options. So we have to use them to test and see which one works. So we have to do synthetic division. What's going to go inside the box? 1, 1, negative 7, negative 1, and 6. All of our coefficients go inside the box. Now, which number do you want to test? So let's try 2. Remember, we can try any one of these options. These are the possible answers. But we need to know what are exact answers. So drop down the 1. We're doing synthetic division here. Multiply the outside, add the inside. We get 6, negative 1, negative 2, negative 3, negative 6, and 0. Does it work? Yes. If you get 0 as your remainder, it works. So now my question started with x to the 4th power. So what's this answer going to start with? X to the 3rd plus 3x squared minus 1x minus 3. Now from here, we could either factor or we could do last over first again. If it doesn't factor, you would have to do last over first again. We have 4 terms, so we could try factoring by grouping, but let's say we didn't know that since we still have a lot of terms going. We could do last over first again. So let's try it again. But now I'm going to put the answers here inside the box. So inside the box I have 1, 3, negative 1, and negative 3. Now I have different numbers for the last, so it just kind of narrows it down a little bit. My factors of 3 are just going to be 1 or 3, positive or negative 1 or 3. So what do you want to try? Negative 3, negative 1, let's do negative 1. So we drop down the 1, multiply the outside, add the inside, so we get 2, negative 2, negative 3, positive 3, 0. So it works. Perfect. So I have 2 solutions so far because you know that both of these work. What's my answer here going to start with? X squared, because this one was x cubed. So here I have 1x squared plus 2x minus 3. You could do last over first again, or we can just see if this factors. It's a quadratic, so it would just factor like normal. Do I have 2 factors of negative 3 that add to 2? Three and negative 1. So this would be x plus 3 and x minus 1. Set it equal to 0 and solve. So what does x equal? Negative 3 and positive 1. So for number 6, what are my answers? 2, negative 1, the ones that I found when doing last over first, and then my answers here when I factored negative 3 and positive 1. Doesn't matter the order. Because we could have tried positive 1 first, and you would have ended up with the same numbers. It would have just been different steps, but you'd get the same. So these are our 4 answers. All right, next I want to take a look at 13. So we said if we have a square root or an I, we need a pair for that number. We need its conjugate pair. So am I missing any zeros for 13? Negative square root 3. Since I had positive square root 3, I needed its pair. So now I'm going to put this into factored form, and then I have to multiply it out. So remember, it's always x minus the number. So we would have x minus 2. What would come next? X minus square root 3, and awesome, it would turn into x plus square root 3 because it'd be x minus a negative. Perfect. Now, which 2 here would we want to multiply out first? The square root 3's. The conjugates. That way we can get rid of them. Now, we can FOIL, or we could do the shortcut. I'm going to do the shortcut. So we have our first term squared minus the second term squared. So this would be x squared minus square root 3 squared. What is square root 3 squared? Just 3. Because the square root and the squared cancel. So this would be x squared minus 3. What do I have to do next? I still have to multiply the x minus 2 to it. So then from here, we just have to FOIL it out. So multiply the first ones, we get x cubed, the outsides, negative 3x, the insides, be negative 2x squared, and then the last would be plus 6. Can I leave my answer like this? No, why not? I have to put it in standard form. So x cubed minus 2x squared minus 3x plus 6. That would be our answer. All right, let's look at the next part. So the next part is that we just are leaving our answer in factored forms. It's the same thing. We have to find our missing terms, our missing zeros, but then we're just leaving it in factored form. So for number 12, what are zeros that are missing? Negative 2i, perfect, because I have an I here, so it needs its pair. What else? 1 plus I, awesome, because this one needed its conjugate pair too. So just the sign of the I or the square root changes. The number here stays the same. So that one part, the real part, stays the same. So just the I or the square root would change its sign. So if we're putting this into factored form, it's always x minus. So x minus 2i. The order doesn't matter, so we could just list them off. What would come next? X plus 2i, we could say. So x minus 1 minus I, and what else? X minus 1 plus I. Perfect. That would be our answer. Just leave it like that. If it says leave it in factored form, you just leave it like this. You do not have to multiply it out. You're not going to get extra points if you multiply it out. Just leave it like this. This is right. All right, let's also look at 13. So 13, again, just says to leave in factored form. Am I missing any zeros here? Square root 7. Since I had a negative square root 7, I need its partner, so positive square root 7. How would I write this in factored form? X minus 3, x plus square root 7, and x minus square root 7. Awesome. So this would be our answer.